If you want to run a characterization using RokCell, open RokCell and ensure that you are in the correct mode. So here I will make the characterization of a SIG porous sample in the frequency domain. So I choose the Johnson-Champower-Lafarge mode. There's also a time domain mode for liners and a frequency domain to characterize facing screens. So Johnson-Champower-Lafarge mode, and now I can load an impedance tube measurement for a material sample using this add or plus button. My sample is this one, the .rok file, which contains the impedance tube measurements. There's also an IAK file which contains information about the static pressure information, sample thickness, and other information. A SIG file which contains information about the direct measurement of the static flow resistivity using the ISO standard, and a RKS file which are a project file for Roxell who will use it at the end. So I select the ROK file, the measurement from the impedance tube. And we can see that here we have the measurement in gray of the sound absorption coefficient, and in black it's a first simulation which is not consistent with measurement yet because we have not run the characterization. I can of course display other type of information like the surface impedance. So in black and green these are the first simulations, and in gray and blue the measurements. Here are the curve for the reflection coefficient. So I go back to the sound absorption coefficient, and now I will run the characterization by selecting my sample. It's already selected because there's only one, and I run the characterization by clicking on this button. It opens a new window with information about the atmospheric parameters which have been read from the RK file. The sample thickness also read from the IRK file. I choose the Johnson-Champower-Lafarge model, but I can choose other type of model like the Johnson-Champower model, the Delaney-Basley-Mickey model, or the Hammett model. I will not use the elastic parameters because I have no information about the elastic parameters yet. And here you have the information about the acoustic parameters. So you have to enter a value for the porosity. So by default, for me it's the correct porosity, 0.99, but you can enter, of course, every value you want. And here we can see that Roxell has already loaded the SIG file we have for this sample, but we can have an estimation of the static airflow resistivity by clicking on this button, and we adjust. For this time it's a fit of the curve, the measurement curve, so I adjust the fit, okay, and we can see that we have good correspondence between the estimated from the impedance tube value, the estimated value of the static airflow resistivity from the impedance tube and the direct measurement. So anyway, I will keep this direct measurement value, and now I will click on this button. So here I can see the dynamic mass density, and from this information we can get the tortuosity, the value of the tortuosity here that I adjust with these two lines, the red and the green one, and it takes the probabilistic value between these two lines or a mean value, but you should usually stick to the probabilistic value. Okay, so I have an estimation for the tortuosity here, and below it's an estimation for the viscous characteristic length. Again, I adjust the frequency range by moving the green and red curve. Okay, we can see that there's no influence here, which is a good point, as this value should be, of course, real values and not depending on the frequency. And we can see that the model has been adjusted in black and green compared to measurement, and we have a quite good estimation. We can see what it gives on the sound absorption coefficient, and we already have a good agreement between measurement and simulation. We'll go to the bulk modulus. So here we can see the real part and the imaginary part of the bulk modulus, and we can adjust the value for the thermal characteristic length. There's nothing to adjust here. And for the static thermal permeability. So I will just move this green line to have an estimation in the low frequency range, because this parameter, the static thermal permeability, is a low frequency parameter. And we can see that the probabilistic value is 62. And if I'm happy with this characterization, I can click on the green button. If I'm not happy, I click on the red cross. I'm happy, I click this one. It asks me to save the project, and so I will use the RKS file. Okay, project is saved. And I go back to the main window, where I can see that we have a good agreement between measurement in gray and simulation in black. It's not fit. We can probably have a better fitting between measurement and simulation, but we, as we have already said, this technique is based on analytical inversion rather than on fit. That's all.